students, yeah, just a little bit about the P7 maybe. Angles are always done in the radians. So dimensionless. And never do it with degrees. And how do you do it in radians? Why are they dimensionless? Now if you have the xy plane 0 and you have some circle with some radius r, then you have here that circle. Now you can go to beneath also, see here minus r, here minus r, and you have some angle. Now then the length from 0 to the circle is r. The path along the circle, that is the angle times the radius, and so or I can better write down the angle in radians, and so you see if you divide those, this is length, the r is length, and so if you divide that phi r by r, you get phi out of it, and so you have dimensionless. And that you cannot do with angles. So we always do in radians, and please do it also radians. Important. And I hope that you saw that the sine and the cosine are always between the absolute value is always less or equal to 1. But the tangent can go from minus infinity to plus infinity. And then some graphs. Just to keep in mind y, x, pi, 2 pi, minus pi, minus 2 pi, 0. Now the sine of 0, and then you have also plus 1 and minus 1. Now and then the sine is 0 and 0. In pi divided by 2 it is equal to 1. So it goes straight up, goes down, and goes down, up, and here it will be equal to minus 1, there it will be equal to 1, and on the other side exactly the same. Now this I have to do a little bit bomb, and here you have, so now the cosine is equal to 1 in 0, and then pi divided by 2 is 0, and in pi it is minus 1, and 0 in 3 pi divided by 2, and in 2 pi it is equal to 1, and again. So here you have the cosine. Now this is not going so well, but okay, I hope you see. Y is the sine of x, and the red one, y is the cosine of x. And then you have all kinds of other things. The sine of minus x is minus the sine of x, the cosine of x is minus x is equal to the cosine of x, etc. All kinds of other formulas. Then the tangent, now near pi divided by 2, and you have decided you have the sine divided by the cosine. So if the cosine becomes 0, you get problems. And so you have here the tangent, the tangent in 0 is 0, and then it goes straight up, and it goes in this way. You have when the cosine becomes 0, the tangent goes to infinity or minus infinity. It just depends on what kind of, or what place you come, from what side you come. Keep in mind. But now, an important chapter, a section 1.2, and it's important because there we get the limits of functions. And those limits we will see very often later on also. Yeah, what does it mean? You write it down as follows. You can take the limit and then you say that the x goes to some fixed point a, some fixed value a, and if you want to take the limit of that function, then there can come out some c, that c is the limit, and we assume that it's always a finite number, so that it not will becomes infinite. So we have no limits, which we shall never say limit is infinite or minus infinity or plus infinity. No, we have always a finite number for our limit, and if it doesn't go well, we say that our limit does not exist. Yeah, what to do? what does it mean? That may be important. If you have some x-axis here, you have some y-axis here, you have the 0, you have some function, the graph of some function. Assume that we can draw a graph. So here you have the y's of fx. Here we have our a. Then we have here our limit c. And what does it mean? It means, the meaning is the following. If we take some small area around C, we have always to find an area around A, such that if we calculate values in that small area here, they have always to be in that surrounding around C. So you have you take first small area around C, small, that is the first a small area around C. And then you have to, has always to be a small area around A. So around A, such that for every value in that small area you become in that small area around C. Such that for every x in so that's it. Let I not write it completely down, but that is the important fact. So you look first to a small area C, then you look if you can find a small, there has to be a small area around A, so that if you take an x out of it, and then the fx has to be in small area of A. There I mean C. But the important fact is so that if the limit exists, then you first look to the y-axis. There you take some small area, and then you have to find a small area, such that for every x out of that area you also come into that small area of C. If you can do that, and if you can do that for every small area around C, then that limit exists. Then limit exists. So if you can do that for every small area, then the limit exists. And that is sometimes difficult to do. Therefore I let now see several examples from how to calculate those limits. Now, for instance, the limit from x going to 1 for x squared minus 1 divided by x minus 1. Now, you see here that we have in certain sense we are busy with rational functions, and here you see also rational function. You see here, if you fill in a 1, you get a 1 minus 1 divided by 1 minus 1, that is 0 divided by 0, and 0 divided by 0, I don't know what to do with it. So you have to do more, you have to go further on. Now, what can we do? I see already the x squared minus 1. We know that we can write it in another form as x minus 1 times x plus 1, and you are dividing by x minus 1, and so you see that you can two terms are falling away, and you see that this is the same as the limit from x going to 1 of the function x plus 1. Now, and that gives you 2. No, yeah, that gives you 2. Now, and so maybe we can also do another one. We can ook do from the x from going to, what shall we do, minus 1, and then x plus 1 divided by x squared minus 1. Now fill in minus 1, that I should always do first, fill in and look if something comes out of it. But here what do we have? 0 divided by 0, same problem, I don't know. We have to do some calculations. So I see the x squared minus 1. I think that maybe it is nice to write it as a product of polynomials of first degree, and what we have then we have x plus 1 times x minus 1, and you see that the x plus 1 are falling away, and then you can fill in minus 1, and we have minus 1 over 2. Now, and on all these, on this way, you can calculate limits. What is of importance, maybe the next one, and then I write down some limits from x going to 0. For instance, x to the power 4 and x to the power 2, and then look to those powers. The power of the numerator is higher than the power of the denominator, and here if we fill in, we get 0 divided by 0, but if we divide out, we get x squared, and we get 0 out of it. So this limit exists. What can we also do? We can change the rule, for instance, x squared divided by x4. Now, what do we have then? Look to those powers. The power of the numerator is lower than the power of the denominator, but we can divide something away, and we get 1 divided by x squared, and if we let x go to infinity, you see that you get infinity or something out of it, but that we say does not exist. So this limit does not exist. Then what can we also do? We can also do x squared divided by x squared. And what do we see? The powers are the same, and now if you divide them to each other, you get 1 out of it. So here you get just the limit from x going to 0 of 1, and that is equal, this is just 1. So, and I hope that you will in the future, or by calculating limits, keep those powers of x in mind. Keep powers of numerator and denominator in mind. But you see that in several so there are two are going well if the powers are equal, and if the power of the numerator is greater than the power of the denominator, then it go well. If the other way, it doesn't go. Now, what can we do? Or the limit from x going to -2 of x squared plus x minus 2 divided by x squared plus 5 times x plus 6. Now if we fill in -2, we get, what do we get? We get 0 divided by 0. So that is, we have to do something. And what can we do? Yeah, because we get 0 out of, we are filling in those polynomials, we get 0 out of that, means that x is -2 is a 0 of both polynomials. So we can try to write, to divide them out. Now, so x -2, what need we in the numerator? If we have to multiply certainly by x, then we have x squared minus 2x. But we have to get x, I mean, yeah, x plus 2 is a component, so x is -2 gives 0 divided by 0. That means x -2 factor of polynomials. Nee, x plus 2. So be careful. You see also that I am making mistakes. X plus 2 is a factor. And what does it mean for the numerator? That we have to multiply by x minus 1. You get x squared, and then we have plus x minus 2. That goes well. And beneath, what to do there? We have 5 and 6, and I think something with 3 and 2. And 3 times 2 is 6, and 2 plus 3 is 5. Yes, we have here. And then we see that we can divide those x plus 2 away by each other, and we have the limit from x going to -2 of x minus 1 divided by x plus 3. And here we can just fill in, and we have -3 divided by 1, and so we have just -3 as the limit. No. And so you can go on with all kind of limits. For instance, the x going to 4 of the square root of x minus 2, and here we have not a polynomial anymore. The polynomials are just powers of, so x to the power 1, x squared, x to the power 3, but x, the square root of x is not a polynomial. But what can we try to do? Yes, x squared minus 16, that I can write as x minus 4 times x plus 4. Sorry, x plus 4, yeah. And then I am thinking to myself that the square root of x times the square root of x is x. So what can we do? We can write that first term as something as the square root of x minus 2 times the square root of x plus 2. Look yourself, you have then the square root of x times that gives you the x, the minus 2 times the plus 2 gives you minus 4, and the other two terms falling away. Yes, and so we can rewrite this expression as square root of x minus 2 divided by square root of x minus 2 square root of x plus 2, and we have, what do we have? X plus 4. And there you see again certain terms are falling away, and if you go on with your calculations, what do we have then? You have 1 divided by the square root of 4 is 2, so 4 times 4 plus 4. Yes, and that gives you 1 divided by 32. And so you see, with all kind of tricks you can calculate your limit. Then something also to do with the limits. Here we have written the limit goes to a. That means in a sketch that if you have here the x-axis and y-axis, and you have here a, that you can go to that point how you want, and it doesn't matter, you can walk around that point and then still become closer and closer to the point. But if you now ask me how I have come to the point, I don't know, but I see I have at a certain moment I came to the point. That is always very good to think, because if you can do that for every way on this, then and you still get the same value, then the limit exists. That is no problem. Then you have, and you still get c out of it, then that limit is equal to c, no problem. But you can also have the sine function, for instance. X divided by the absolute value of x, and then you can also say, from now I take the limit from above to 0. And from above to 0, that means that you only may do it with paths which are where the x is positive and becomes smaller and smaller and smaller. Now, so this means if you go above to some point, in this case, that your x is only positive. And the sine function was not defined for x is 0, so you have only positive value of x. Now, and if you take the limit from above, you get the limit from above to 0, because the x is 0, the absolute value is x, and you get 1 out of it. And so you can also try to calculate the limit if x goes from beneath to 0 of that same function. And that means that you have the limit from x going to beneath. And what do you have then? From beneath, that means that the x is always negative. And what do we have then? Then you have x divided by minus x. And the absolute, you have to take the value, the absolute value of x, and in this case it becomes minus x, and then you see that you get minus 1 out of it. And here you see that those limits are not equal. In this case, the limit from above going to 0 is not equal to the limit from x going from beneath to 0, and therefore the limit in x0 does not exist. If x goes to 0 of that function, it is not told to you how to go to that point. So you go to you go to 0 on some different ways, and you get different values out of it, so the limit does not exist. In Adams, the limit from going to above to 0 of something will be written as the limit from x going to 0 plus. And the limit from x going from beneath to 0, that will be written down as the limit from x going to 0 minus. So you are here and here. Now, so this is the right limit, and the other one is the right limit and the left limit. Now, and there I want to stop with those limits as a first introduction to limits, and then later on we go further with those limits, and then not later on the next time, and then we will see what kind of things you may do with those limits, and we will look to all kinds of limits, and we need those limits by defining derivatives. So here you see that limits are very often used with all kinds of things. And sometimes we do certain operations where we use those limits, but we don't know that we use them. We are just calculating things without in mind about that in certain sense we are calculating some limit. Now let's stop here. Really stop.